Hello everyone, welcome to the lecture on database systems. And in this lecture, we shall be looking at the following learning outcomes. Learning outcome number one, you will learn the difference between data and information. Learning outcome number two, what a database is, the various types of databases, and why they are valuable assets for decision making. 3, the importance of database design. 4, how modern databases evolve from file systems. Objective number 5, what are some of the flaws or problems in file systems data management? Learning outcome number 6, the main components of database system. And finally, we shall look at the main functions of a database management system, also called as a DBMS. Good decisions require good information that is derived from raw facts. These raw facts are known as data. Data are likely to be managed most efficiently when they are stored in a database. In this lecture, you will learn what a database is, what it does, and why it yields better results than other data management methods. You'll also learn about various types of databases and why database design is so important. Database evolved from computer file systems. Although file system data management is now largely outmoded, understanding the characteristics of file systems is important because file systems are the source of serious data management limitations. In this lecture, you'll also learn how the database system approach helps eliminate most of the shortcomings of file system and data management. Why databases? Imagine trying to operate a business without knowing who your customers are, what products you are selling, who is working for you, who owes you money, and whom you owe money. All businesses have to keep this type of data and much more. And just as importantly, they must have those data available to decision makers when they need them. It can be argued that the ultimate purpose of all business information systems is to help businesses use information as an organizational resource. At the heart of all these systems are the collection, storage, aggregation, manipulation, dissemination, and management of data. Now, databases are used almost in all modern settings involving data management. Example in businesses, research, administrations, and many more. So, how do these businesses process data? How can they store it all and then quickly retrieve just the facts that decision makers want to know, just when they want to know it? The answer is that they use databases. Databases allow computer-based systems to store, manage, and retrieve data very, very quickly. Data versus information. Data are raw facts. The word raw indicates that the facts have not been processed to reveal their meaning. Information is a result of processing raw data to reveal its meaning. Data processing can be as simple as organizing data to reveal patterns, or as complex as making forecasts or drawing inferences using statistical modeling. To reveal meaning, information requires context. Data are the foundation of information, which is the bedrock of knowledge. That is, the body of information and facts about a specific subject. Knowledge implies familiarity, awareness, and understanding of information as it applies to an environment. A key characteristic of knowledge is that new knowledge can be derived from old knowledge. Data versus information continued. Let's summarize some key points in relation to data and information. Data constitute the building blocks of information. Information is produced by processing data. information is used to reveal the meaning of data. Accurate, relevant, and timely information is the key to good decision making. Good decision making is the key to organizational survival in a global environment. Timely and useful information requires accurate data. Such data must be properly generated and stored in a format that is easy to access and process. And like any basic resource, the data environment must be managed carefully. Data management is a discipline that focuses on the proper generation, storage, and retrieval of data. Given the crucial role the data plays, it should not surprise you that data management is a core activity for any business, government agency, service organization, or charity. Introducing the database. Efficient data management typically requires the use of a computer database. A database is a shared, integrated computer structure that stores a collection of end-user data that is raw facts of interest to the end user. Metadata, or data about data, through which the end user data are integrated and managed. The metadata provide a description of the data characteristics and the set of relationships that links the data found within the database. For example, the metadata stores information such as the name of each data element, the type of values, example, numeric, dates, or text, stored on each data element, whether or not the data element can be left empty, and so on. The metadata provide information that complements and expands the value and ease of data. In short, metadata presents a more complete picture of the data in the database. Given the characteristics of metadata, you might hear a database described as a collection of self-describing data. A database management system is a collection of programs that manages the database structure and controls access to the data stored in the database. In a sense, a database resembles a very well-organized electronic filing cabinet in which powerful software, such as database management system, helps manage the cabinet's content. Role and advantages of database management system. The database management system serves as an intermediary between the user and the database. The database structure itself is stored as a collection of files, and the only way to access data in those files is through the database management system. Having a database management system between the end user's applications and the database offers some important advantages. First, the database management system enables the data in the database to be shared among multiple applications or users. Second, the database management system integrates the many different users' view of data into a single all-encompassing data repository. Role and advantages of database management systems continued. Other advantages include improved sharing data. The database management system can help create an environment in which end users have better access to more and better managed data. Such access makes it possible for end user to respond quickly to changes in their environment. Second advantage for the slide is improved data security. The more users access the data, the greater the risks of data security breaches. Corporations invest considerable amount of time, effort, and money to ensure that corporate data are properly used. A database management system provides a framework for better enforcement of data privacy and security policies. Next advantage, better data integration. Wider access to well-managed data promotes an integrated view of organizations' operations and a clearer view of the big picture. It becomes much easier to see how actions in one segment of the company affect the other segment. Next advantage, minimize data inconsistencies. Data inconsistencies exists when different versions of the same data appear in different places. For example, data inconsistencies exist when a company's sales department stores a sales representative's name as Bill Brown and the company's personal department stores the same person's name as William Brown. Or when the company's regional sales office shows the price of a product as $45.95 and the national sales office shows the same product's price as $49.55. The probability of data inconsistency is greater, reduced in a properly designed database. Next advantage is improved data access. The database management system makes it possible to produce quick answers to ad hoc queries. From a database perspective, a query is specific request issued to the database management system for data manipulation. Next advantage is improved decision making. Better managed data and improved data access make it possible to generate better quality information on which decisions are based. And the final advantage is increased end user productivity. The availability of data combined with the tools that transform data into usable information empowers end users to make quick, informed decisions that make the difference between success and failure in the global economy. Types of databases. A database management system can support many different types of databases. Databases can be classified according to the number of users, the database locations, and expected type and extent of use. The number of users determines whether the database is classified as a single user or multi-user. A single user database supports only one user at a time. In other words, if user A is using the database, users B and C must wait until user A is done. A single user database that runs on a personal computer is called a desktop database. In contrast, a multi-user database supports multiple users at the same time. When the multi-user database supports a relatively small number of users, let's say fewer than 50, or a specific department within an organization, it is called a workgroup database. When the database is used by the entire organization and supports many users across many departments, the database is known as an enterprise database. Types of databases continued. Location might also be used to classify the database. For example, a database that supports data located at a single site is called a centralized database. A centralized database supports data distributed across several sites in a distributed database. Pardon me, let me repeat that. Location might also be used to classify the database. For example, a database that supports data located at a single site is called a centralized database. On the other hand, a database that supports data distributed across several different sites is called a distributed database. The most popular way of classifying databases today, however, is based on how well they will be used and on the time sensitivity of the information gathered from them. For example, transactions such as product or service sales, payments, and supply purchases reflect critical day-to-day operations. Transactions must be recorded accurately and timely. A database that is designed primarily to support a company's day-to-day operations is classified as an operational database, sometimes referred to as a transactional or production database. In contrast, a data warehouse focuses primarily on storing data used to generate information required to make tactical or strategic decisions. Such decisions typically require extensive data messaging or manipulation to extract information to formulate pricing decisions, sales forecasts, market positioning, and so on. Most decision support data are based on data obtained from operational databases over time and stored in data warehouses. Additionally, the data warehouse can store data derived from many sources. To make it easier to retrieve such data, the data warehouse's structure is quite different from that of an operational or transactional database. Types of databases continued. Databases can also be classified to reflect the degree to which the data are structured. Unstructured data are data that exist in their original or raw state, that is, in the format in which they were collected. Therefore, unstructured data exists in a format that does not lend itself to the processing that yields information. Structured data are the result of taking unstructured data and formatting or structuring such data to facilitate storage, use, and the generation of information. You can apply structure or format based on the type of processing that you intend to perform on the data. Some data might not be ready, unstructured for some types of processing, but they might be ready or structured for other types of processing. For example, the data value 37890 might refer to a zip code, a sales value, or a product code. If this value represents a zip code or product code and is stored as text, you cannot perform mathematical computations on it. On the other hand, if this value represents a sales transaction, it is necessary to format it as numeric. Why database design is important. A database design refers to the activities that focus on the design of the database structure and that would be used to store and manage end user data. A database that meets all user requirements does not just happen. Its structure might be designed carefully. In fact, database design is such a crucial aspect of working with databases. Even a good database management system will perform poorly with a badly designed database. Proper database design requires a designer to identify precisely the database's expected use. Else, a poorly designed database causes difficulties in tracing errors. Evolution of file system data processing. Understanding what a database is and what it does and the proper way to use it can be clarified by considering what a database is not. A brief explanation of the evolution of file system data processing can be helpful in understanding the data access limitations that database attempt to overcome. Understanding these limitations is relevant to database designers and developers because database technologies do not make these problems magically disappear. Database technologies simply make it easier to create solutions that avoid these problems. Creating database designs that avoid the pitfalls of earlier systems requires that the designer understand what the problem of the earlier systems were and how to avoid them, or else the database technologies are no better or potentially even worse than the technologies and techniques they have replaced. Evolution of file system data processing continued. In order to be successful, an organization must come up with systems for handling core business tasks. Historically, such systems were often manual, paper, and pencil systems. The paper within these systems were organized in order to facilitate the expected use of data. Typically, this was accomplished through a system of file folders and filing cabinets. As long as a data collection was relatively small and an organization's business users had few reporting requirements, the manual system serves its role well as a data repository. However, as organizations grew and as reporting requirements became more complex, keeping track of data in a manual file system became more difficult. Therefore, companies looked to computer technology for help. Generating reports from manual file systems was slow and cumbersome. In fact, some business managers faced government-imposed reporting documents that required weeks of extensive effort each quarter, even when a well-designed manual system was used. Therefore, a data processing specialist was hired to create a computer-based system that would track data and produce required documents. The data processing specialist converted manual file systems into a computerized file systems. Problem with file system data processing. The file system method of organizing and managing data was a definite improvement over the manual system. The file system served a useful purpose in data management over 2 decades, a very long time in the computer era. Nonetheless, many problems and limitations became evident in this approach. A critique of the file system method serves 2 purposes. Understanding the shortcomings of the file enables you to understand the development of modern databases. Many of the problems are not unique to file systems. Failure to understand such problems is likely to lead to their duplication in a database environment, even though database technology makes it easy to avoid them. Other problems include lengthy development time. The first and foremost problem with the file system approach is that even the simplest data retrieval task requires extensive programming. With the older file systems, programmers had to specify what must be done and how it was to be done. The next problem is difficulty of getting quick answers. The need to write programs to produce even the simplest reports makes ad hoc queries impossible. And complex system administration is the next problem. System administration becomes more difficult as the number of files in the system expand. Even a simple file system with a few files requires creating and maintaining several file systems and programs. Problems with file system data processing continued. Lack of security and limited data sharing. Another fault of a file system data repository is a lack of security and limited data sharing. Data sharing and security are closely related. Sharing data among multiple geographically dispersed users introduces a lot of security risks. Extensive programming. Making changes to an existing file structure can be difficult in a file system environment. Structural and data dependence. A file system exhibits structural dependence, which means that access to a file is dependent on its structure. File system application programs are affected by change in the file structure that exhibit structural dependence. Conversely, structural independence exists when it is possible to make changes in the file structure without affecting the application program's ability to access the data. Even changes in the characteristics of data, such as changing a field from integer to decimal, require changes in all programs that access the file. Because all data access programs are subject to change when any of the file's data storage characteristics change, that is changing the data type, the file system is said to exhibit data dependence. Conversely, data independence exists when it is possible to make changes in these data storage characteristics without affecting the program's ability to access the data. Structural and data dependence continued. The practical significance of data dependence is the difference between the logical data format, that is how the human beings view the data, and the physical data format, that is how the computer must work with the data. Any program that accesses a file system's file must tell the computer not only what to do, but also how to do it. Consequently, Each program must contain files to specify the opening of a specific file type, its record specification, and its field definition. Data dependence makes the file system extremely cumbersome from the point of view of a programmer and database manager. Data redundancy. Data redundancy exists when the same data are stored unnecessarily at different places. Uncontrolled data redundancy sets the stage for poor data security. Having multiple copies of data increases the chances for a copy of the data to be susceptible to unauthorized access. Data redundancy continued. Data redundancy also leads to data inconsistency. Data inconsistency exists when different and conflicting versions of the same data appear in different places. Data anomalies. The dictionary defines anomaly as an abnormality. Ideally, a field value change should be made in only a single place. Data redundancy, however, fosters an abnormal condition by forcing field value changes in many different locations. The data anomalies commonly found are update, insert, and deletion anomalies. The database system environment. The term database system refers to an organization of components that define and regulate the collection, storage, management, and use of data within a database environment. From a general management point of view, the database system is composed of the 5 major parts. These are hardware, software, people, procedures, and data. Let's have a look at more broadly at these 5 major parts. Hardware. Hardware refers to all the system's physical devices, for example, computers in terms of PCs, workstations, servers, and supercomputers, storage devices, printers, network hubs, switches, routers, fiber optic cables, and other devices. Software. Although the most readily identified software is the database management system itself, to make the database fully functional, 3 types of software are needed: operating system software, database management system software, and application programs and utilities. People. This component includes all users of the database system. On the basis of primary job functions, 5 types of users can be identified in a database system: system administrators, database administrators, database designers, system analysts, and programmers, and end users. Each user type performs both unique and complementary functions. Procedures. Procedures are the instructions and rules that govern the design and use of the database system. Procedures are critical, although occasionally forgotten components of the system. Procedures play an important role in a company because they enforce the standards by which businesses conduct within the organization and with their customers. Procedures are also used to ensure that there is an organized way to monitor and audit both the data that enter the database and the information that is generated through the use of those data. And finally, data. The word data covers a collection of facts stored in the database. Because data are the raw materials from which information is generated, the determination of what data are to be entered into the database and how those data are to be organized is a vital part of the database designer's job. Database management system functions. A database management system performs several functions that guarantee the integrity and consistency of data in the database. Most of those functions are transparent to end users, and most can be achieved only through the use of a database management system. They include data dictionary management, data storage management, data transformation and presentation, security management, multi-user access control, backup and recovery management, data integrity management, database access languages and application programming interfaces, and database communication interfaces. Data dictionary management. This is the first of the functions. So let's go and have a look at what data dictionary management is. The database management system stores definitions of the data elements and their relationships in a data dictionary. In turn, all programs that access the data in the database work through the database management system. The database management system uses the data dictionary to look up the required data component structures and relationships, thus relieving you from having to code such complex relationships in each program. Additionally, any changes made in a database structure are automatically recorded in the data dictionary, thereby freeing you from having to modify all of the programs that access the changed structure. DBMS functions continued. Data storage management. The database management system creates and manages the complex structures required for data storage, thus relieving you from the difficult task of defining and programming the physical data characteristics. A modern database management system provides storage not only for the data, but also for related data entry forms or screen definitions, report definitions, data validation rules, procedural code, structures to handle video and picture formats, and so on. Data storage management is also important for database performance tuning. Performance tuning relates to the activities that make the database perform more efficiently in terms of storage and access speed. Although the user sees the database as a single data storage unit, the database management system actually stores the database in multiple physical data files. The next function is data transformation and presentation. The database management system transforms entered data to conform to required data structures. The database management system relieves you of the chore of making a distinction between the logical data format and the physical data format. That is, the database management system formats the physical retrieved data to make it conform to the user's logical expectations. Security management. The database management system creates a security system that enforces user security and data privacy. Security rules determine which user can access the database, which data items each user can access, and which data operations the user can perform. This is especially important in multi-user database systems. The next function of database management system is multi-user access control. To provide data integrity and data consistency, the database management system uses a sophisticated algorithm or algorithms to ensure that multiple users can access the database concurrently without compromising the integrity of the database. Backup and recovery management is the next function. The database management system provides backup and data recovery to ensure data safety and integrity. Current database management systems provide special utilities that allow the database administrator to perform routine and special backup and restore procedures. Recovery management deals with the recovery of the database after a failure, such as a bad sector in the disk or power failure. Such capability is critical to preserving the database's integrity. Next function of the database management system is data integrity management. The database management system promotes and enforces integrity rules, thus minimizes data redundancy and maximizes data consistency. The data relationships stored in the data dictionary are used to enforce data integrity, Ensuring data integrity is especially important in transaction-oriented database systems. The next function of database management system is database access languages and application programming interfaces. The database management system provides data access through a query language. A query language is a non-procedural language, one that lets the user specify what must be done without having to specify how it is to be done. SQL is the de facto query language and data access standard supported by the majority of the database management system vendors. The next function is database communication interfaces. Current generation database management systems accept end user requests via multiple different network environments. In this environment, communications can be accomplished in several ways. End user can generate answers to queries by filling in screen forms through their preferred web browser. The database management system can automatically publish predefined reports on a database. The database management system can connect with third-party systems to distribute information via email or other productivity applications. Managing the database system, a shift in focus. The introduction of a database system over the file system provides a framework in which strict procedures and standards are or can be enforced. Consequently, the role of human component changes from an emphasis on programming to a focus on the broader aspects of managing the organization's data resources and on the administration of the complex database software itself. The database system makes it possible to tackle far more sophisticated uses of data resources as long as the database is designed to make use of the available power. The kinds of data structures created within the database and the extent of the relationship among a powerful role in determining the effectiveness of the database system. Managing the database system, a shift in focus continued. Although the database system yields considerable advantages over previous data management approaches, database systems do carry significant disadvantages. For example, increased costs. Database systems require sophisticated hardware and software and highly skilled personnel. The cost of maintaining the hardware, software, and personnel required to operate and manage a database system can be substantial. Training, licensing, and regulation compliance costs are often overlooked when database systems are implemented. Next disadvantage, management complexity. Database system interface with many different technologies and have a significant impact on a company's resources and culture. The changes introduced by the adoption of a database system must be properly managed to ensure that they have advanced the company's objective. Given the fact that database systems hold crucial company data that are accessed from multiple sources, security issues must be assessed constantly. Next disadvantage is maintaining currency. To maximize the efficiency of the database system, you must keep your system current. Therefore, you must perform frequent updates and apply the latest patches and security measures to all components. Because database technology advances rapidly, personnel training costs tend to be significant. Next disadvantage is vendor dependence. Given the heavy investment in technology and personnel training, companies might be reluctant to change database vendors. As a consequence, vendors are less likely to offer pricing point advantages to existing customers, and those customers might be limited in their choice of database system components. And the final disadvantage is frequent upgrade or replacement cycles. Database management system vendors frequently upgrade their product by adding new functionality. Such new features often come in bundled packages or bundled in upgrade versions of the software. Some of these versions require hardware upgrades even. Not only do the upgrades themselves cost money, but it also costs money to train database users and administrators to properly use and manage the new features. Let's go and summarize the lecture. Data are raw facts. Information is the result of processing data to reveal its meaning. Accurate, relevant, and timely information is the key to good decision making. Data are usually stored in a database. Database management system implements a database and manages its content. Metadata is data about data. Database design defines the database structure. Well-defined database facilitates data management and generates valuable information. Poorly designed database leads to bad decision-making and organizational failure. Databases evolved from manual and computerized file systems. In a file system, data stored in dependent files each require its own management program. Some limitations of file system data management are: requires extensive programming, system administration is complex and difficult, changing existing structures is difficult, security features are likely inadequate, dependent files tend to contain redundant data, structural and data dependency problems. Database management systems were developed to address file systems' inherent weaknesses. Database management systems present database to end user as single repository, promotes data sharing, eliminates islands of information. Database management system enforces data integrity, eliminates redundancy, and promotes security. So this finishes our lecture on database systems. Thank you for listening, everyone.